So let's talk about an inclined ramp. Here's my inclined ramp. Here is my object. Okay. Now, when I've got an object on an inclined ramp, currently my inclined ramp has an incline of 0 degrees. Okay. All right. So, but when I make that ramp become a little more inclined, okay, then stay with me, roll of paper towels. Okay, it's going to tip over. I don't want it to tip over. Okay, the farther I get, then what's going to happen to this roll of paper towels? It's going to slide down the ramp, right? Okay, so what in this, when I'm at this kind of an incline, what's preventing this roll of paper towels from sliding down the ramp? Friction. Okay? So we've got a frictional force that's at play. Okay? All right? On an inclined ramp, that frictional force, you gonna make it?
I don't think so.
Okay, I get it.
I was just testing gravity to make sure it's still working.
I hope it is. That frictional force runs parallel to your surface. I don't like my S. Whoa. Now I like my S. So that runs parallel to the surface. Okay? What other forces are at work? Max. Gravity's at work, yeah. Okay? Gravity is working in the vertical motion. It's pulling that object down. It's not pulling it down this way, okay? Because that gravity doesn't work at an angle. Gravity works vertically. You gonna give me the last one? Okay, give me a second. Okay? How can I measure gravity? So really just because the gravitational constant's always going to be there, right? Okay? So really it's just the weight, right? Because that 9.8 is going to be the same if it's me, if it's the Tervis cup back there, or if it's, a big old boulder, right? Okay? All right? So really, gravity is just your weight. Okay? So, note to self. So usually we find that gravitational force because we'll tell you how heavy an object is. Right? That's on our ramp. Okay, Max, give me the last one. The normal force. Yep. Our normal force is the other one. And can somebody explain to me what a normal force is? Anybody? Go ahead.
Normal force is just basically the surface pushing back against the object.
So it's kind of like what's keeping me, instead of being a puddle on the floor, it's keeping me up, right?
Yeah, instead of going through the floor,
Yeah.
the floor is pushing back up on you.
Yeah, floor's pushing back on me. Okay, it's a little resistance action going on. Okay, so that's my normal force. And does anybody know the relationship in here with all of the things present that the normal force is?
If the object is not moving, then gravity.
No, not yet. Just give me an angle of the normal force. It is not straight up and down.
Straight up towards the object. Like with
So it is.
It's like a 90-degree angle, right angle.
So it's perpendicular to the surface, right? So it's perpendicular to friction, really. Okay? All right? With me? There's one other thing. It's not a force, but there's one other thing at work here, and that is the angle of my incline. Okay? And that angle of incline comes off of the horizontal. Okay? All right? Now, who is going to tell me the relationship between all three forces?
Okay, so the friction is related to the F component of the normal force.
Okay. So what if my object is at rest? Let's go that way, because we're only going to have object at rest problems. So if my object is at rest on my inclined plane, what is the relationship between all three forces? So the net of the forces. So how do I find F net? I add up all the forces. So my normal force plus my friction force plus my gravitational force is going to end up canceling everything out and have a resultant vector of 0. If my object is at rest. Yes? Yes. Okay. All right. Now, let's do some funky representation. I'm going to take those three forces and I'm going to move them around a little bit. Okay? So, if I take my gravitational force, it's vertical, correct? Okay? So that's going to be my gravitational force right there. Okay? Then I've got a frictional force that runs parallel to my inclined plane, correct? Okay. So that's going to be my friction. Then I've got a normal force that runs. Oops, my friction force is a little too long. We'll have to fix that. Then I've got my normal force, which is perpendicular to the surface. And since friction is running along the surface, that means that friction and normal forces are perpendicular. Right? And then I've got my incline angle. Right? Knowing what you know about geometry, do I know any other angles? Dylan?
Well, now the angle that's coming G and F would be 90 minus whatever the information angle.
So that one's going to be 90 minus my incline, right? Okay. Which means what? That what? And that third angle is going to be the same as this angle up here is going to be my incline angle based off of the fact that the three angles of a triangle have to add up to be 180 degrees. And if one of them is 90 degrees, then the other two have to add up to be 90 degrees. And then the purple and the, we'll call it orange down here, add up to be 90 degrees. So, yeah, right? Okay. Now, that is crucial because this triangle right here is how you're going to solve all of your incline ramp problems. Okay? Let's dive into one. So we've got a 58-pound object at rest. That's key. It's at rest, so all of our forces cancel out, on a ramp with an incline angle of 16 degrees. Find the friction force and the normal force. Well, let's set up our triangle. So we've got a 58-pound object. That's going to be my gravitational force because it's weight, right? At rest on a ramp with an incline angle of 16 degrees, which then means that this angle up there is also 16 degrees. We need to find the friction, and we need to find the normal. Okay? How are we going to find friction? How are we going to find normal? Yep. SOHCAHTOA. Yep. Makes it easy on us. Don't have to do any figuring other than SOHCAHTOA. A little RTT for you. That's right triangle trait. Okay? SOHCAHTOA. Alright? So, if I'm finding my normal force first, that means I'm going to find the cosine of 16 degrees is equal to the adjacent side, which is my normal side, over my hypotenuse, which is 58. Which means then that the normal force here is going to be 58 times the cosine of 16 degrees. The sine of 16 degrees is going to be equal to my frictional force over the hypotenuse, which is 58. So F is going to be 58 times the sine of 16 degrees. Okay? When you type those in on a calculadora, you should get your normal force is 55.7532 pounds, because that's what my forces are being labeled as in this one. Okay? And my frictional force should be 15.987 pounds. Whatever you want. I just put it out there just to put it out there, you know what I mean?
Yeah.
And then, so if you wanted to go, we'll tell you on the test. Okay? Yeah? Ready to try one on your own? Let's try that next one. 120-pound object at an angle of 50 degrees, which is a pretty steep ramp. So we should draw in our triangle. So we got there and there. Bless you. And there. And then I know that this angle there is 50 degrees, which makes this be 50 degrees, and we have a 120-pound object there. So then this is going to be F, this is going to be N, so that tells me then that the cosine of 50 degrees is N over 120. N is 120 cosine of 50 degrees. So I get N here as 77.1345 pounds. That might be in newtons, that might be in kilograms, depending upon what we're dealing with in that particular problem. The sine of 50 degrees would be my friction over 120. So that gets me that, which gives me a frictional force of, I got 91.9253 pounds. Yes? 2 things accomplished out of 5. Third thing accomplished. Let's do that last one. Or actually, let's have you do that last one. Okay? 3 forces are working upon an object. Find the direction and magnitude of the resultant vector. Okay? Go for it. So this is a 3 forces type problem. So I need to find the component form of each force. So I'll call it A is going to be 100 times the cosine of 50 degrees and 100 times the sine of 50 degrees, which is going to give me the component form of 64.2788 and 76.6044. Then I have to find vector B. That's going to be 50 times the cosine of 160 degrees and 50 times the sine of 160 degrees. So that's going to be negative 46.9846 and 17.101. Then I have to find the component form of form C, which is 80 times the cosine of negative 20 degrees and 80 times the sine of negative 20 degrees, which is going to be 75.1754 and negative 27.3616. Okay? My resultant vector is going to be the sum of those 3 vectors, which is going to be in component form 92.4695 and 66.3438. From that, then, now I can find the magnitude of my result, which is going to be 92.4695 quantity squared plus 66.3438 quantity squared. Then take the square root of that. That gives me a resultant magnitude of 113.807 pounds. My reference angle is going to be the inverse tangent of y divided by x. I'm in quadrant 1, correct? My resultant vector is in quadrant 1. So because I am in quadrant 1, then my direction angle is equal to my reference angle. So my direction, the direction of my result is going to be 35.6582 degrees. Again, you round to wherever you feel fit to be rounded. Okay? Third goal accomplished. Okay? Now we are done with the white packet. Okay? So we are going to take a quick formative right now, and then when you're done with the formative, I will give you, that was goal number 4. Goal number 5 then is to give you the homework packet number 4 that's due by Monday. Okay?